So now let's check that. Okay, now everyone. So let's wait for it to get better connection. So when it says everything is set, we will go page by page. I will wait for you at each page, and I will ask you that would you like me to solve some examples or not. Whatever example you want me to solve, I'm going to solve them all. There is one problem. I was really very bad for this weekend. I got sick and I barely sit on the desk right now. So I see that. So live lesson is started. It is on right now. So I'm checking from my phone as well. So let's wait for a few more people. If you think that there are some people, some friends of you, who doesn't know about this right now, just write them message, so make them know about this. They can also watch this lesson after we record it. Okay, so right now it is working well. I see that. I have comments in here, 7 watching right now. One of them is me, myself. Is there anyone who wants me to solve these questions? Any one of these questions? Please write it in the comment box if you want me to solve any question from this page. I will wait for 30 seconds, 40 seconds. Not okay. We will go page by page. We have 36 pages, so it's hard to reach. So right now I see no comment. So how else can we do this plan? Normally I want you to send me questions from Viber, WhatsApp. So when I got them from Viber and WhatsApp, I solve them. I find them in here and solve them quickly. It's easier. Right now you can write in the comment box, is there any question from this page that you want me to solve? So that means let's skip this page as well. So if you have my phone number, even if you don't have my phone number, I can give you right now 49487 211. If you send me some photos that from the questions that you studied this weekend, especially from WhatsApp, it's a lot easier for me to reach. It can be from Viber also. You can send some photos from Gmail also. So I only need you to ask me some questions so I can solve them. So let's skip this page as well. I have waited on this page, I think, more than 1 minute. So these are the same questions with the previous page, same type of examples. Let's move to the next one. Do you want me to solve some examples like this? Let's wait in here 1 minute like this. I will be checking the comment box. If you want a question from this page, I'm waiting to see it. So now in extra lessons I don't choose the questions, I want you to choose the questions. Especially for right now, I didn't prepare anything till now. I was checking the exam paper, some other stuff, and I am really feeling bad. So what's that? So about this page, I think no examples. So what about this one, comparing the logarithmic and what about the voice? Is the voice good? Good enough? Okay. Ermal, is it possible that you call Dirilon? Probably he came to the dormitory and he is really surprised. Me too. I'm very surprised. So about this page, I don't see someone asking me questions. Let's move forward to the from this one if there is any questions. So how can I reach to him? So about this page, I don't see it in comment box. Perhaps it was unnecessary to. Okay. Yes, I have one question. Very good. I love that. Okay, is it this page questions? Yes, it's from this page. Okay, one student sent me photos from this page. Let me check the hard one from here. What can be? So these are the questions that I collected over there with the same basis. He also wrote 12, 13, she. I don't know. 12 and 13 want me to solve. Very good. From this page, let's solve 12 and 13. Let's see what they do. So these questions are about kind of like simplifying, calculating, making them together, kind of like that. So to be able to connect the logarithms, there mustn't be anything else, any other number before them, like in here. Look, there is no number, there is no number, there is no number, there is no number, there is no number, no number, no number. So firstly, the numbers that's outside, just before the logarithms, we should put them back into the logarithm, which is like, we can put 3 back into the logarithm as power, and minus 1 over 2, we keep the minus out, we don't move it inside with the sign, just a number. 16 to the power of 1 over 2. Efendim kızım. Yazabilir miyim? Şimdi olmaz kızım. So now the next step after we move powers in, these two signs are important, which is they are all in the log base 10. We are going to collect them. If there is minus, there will be a rational expression. The positive ones will go up, the negative ones will go down. So log base 10, 2 to the power of 3. So it's a positive one. 2 cube goes up. So this is a negative one. 16 can be written as 2 to the power of 4 to the power of 1 over 2 goes to denominator part. Since it is the negative logarithm, positive logarithm 5 goes up as product. So you put them all into one, which is you can collect them again. Bekle kızım. Efendim. Ama şu an ben işim var kızım. So now I am writing all same, I only want to calculate this. 4 times 1 over 2, you multiply power by power. So 4 times 1 over 2 makes 2, 2 squared. So then 2 cube and 2 squared, you can simplify them. 2 cube has like 2 times 2 times 2, 3 of it, and 2 squared has 2 times 2. So if you simplify, that remains 2 to the power of 1, which is log 2 to the power of 1 times 5 makes 10. Log base 10 of 10 is equal to number 1. So now let's take the other question. Let me solve you the other question also. Kızım şu an kucağıma gelemezsin. İçeriden tabure getir. Taburede oturabilirsin. Abiler şu an bizi dinliyorlar. Abiler şu an bizi dinliyorlar. Olmaz. Ayıp şu an. Şu an beni rahatsız etme. Bak abiler evlerinde beni dinliyorlar. Sorry about this. This is my daughter. And she talks a lot. Sorry about that. Okay, wait a second. About the comment box. Okay. Dirilon, right now Ermal and some others probably they went to Viva Fresh, I think, or I don't know, one of them. They are over that there were a few more people came before you. I think Dirilon should be Dirilon. I'm sorry about the dormitory, boys dormitory part. So now I I I never expected such problem. Very dark. We don't listen to dorm. We know my teacher study.
Ödeme bundan yapayım mı?
Evet kızım, şimdi so now yes, I have told you before we can never postpone this one. It's very bad. If you want, I can bring you candles. So I'm really sick right now. I didn't leave the home for 2 days, but if you want, I can come over there, bring you candles. But probably you can buy it from the Viva also, I think. Anyway, I don't want to look the comments right now. So one student wanted me to solve these two examples. This is the second one of them. So we are going to use exactly the same steps. Let's take it back. Equal. So firstly, we will put the numbers in. I think I have asked a question like this as equation in the quiz. Efendim kızım, bak kızmaya başlıyorum, bak ne istiyorsun benden? Kızım ben şimdi iş yapıyorum. Lütfen odana gider misin? Hadi, hadi. Beni rahatsız etme bakayım, hadi. So we are putting 1 over 3 inside there as a power of 125. We put number 2 in there as power of 2. 1 over 2 will go in there as power of 4. So then, since there is no number before logarithms, I can collect them into one logarithm. I can combine them. So let's make parentheses. Since there is, I see a minus sign, it will be a rational expression. Positive 1 2 squared times 125 makes 5 cube to the power of 1 over 3 goes to the numerator part, minus the negative 1 will go to denominator. 4 is 2 squared, and easier for you to see what's happening then. 3 times 1 over 3 makes 1, so that will be just 5. 2 times 1 over 2 will be 1, that will be just 2. 4 times 5, 20 over 2, 10. Log base 10 of 10 equals 1. Exactly same answer. So now, let's check that. Do I... Okay, so right now you are also let's go to the next one. This is the next page. Okay, I will bring you candles, don't worry then. I have to do it as a teacher, I think, or I need to call Scaldonager to buy some. Okay. So now, is there anyone who wants me to solve a question from this page? Let's wait like 30 seconds. If there is no, let's move to the next one. Okay, so an example from page 6. Where is the page 6? I'm so lost about that. Page 6, 11th grade. Let's go 11th grade and find the page 6 in there. Elton has a question. Very well. I like that. Page 6, comparing them. Okay, good. Comparing is the easiest stuff, easiest thing, which is in logarithms and in exponentials, it works the same, which is like if you have the base part, so if the base, let's write base in here, bigger than 1, you have increasing type. If the base smaller than 1, you have decreasing type. Like in here, this is an increasing one, number 5 bigger than 1. So big power, big result. So 4 over 5 bigger than 3 over 4. So you should write that the base 2 over 3 smaller than 1, decreasing. And after that you should write that 5 over 2 and 3. You should compare the powers. So 5 over 2 makes 2.5. So the power 3 is bigger. So then for big power 2 over 3 to the power of 5 over 2, big power small result, it will be inverse 2 over 3 to the power of 3. You should show me these 3 steps. I need to know that you know the idea about the base, you know the idea about comparing the powers. After you compare the powers, you use it for real example. Like in here, 10 over 11 is something smaller than 1. Big power, small number, like minus 6 and minus 5. Minus 5 is bigger than minus 6, so big power, small number. Also in here, base 2 is bigger than 1, so big power 7, big number, not big power actually. So 1 over 3 is smaller than 1, so that means it's decreasing type. For big one there will be small result. Let's check after that. Do I have, can we next solve trigonometry? Okay, thank you. Okay, good. So now let's go page by page. It's better for me. We did some things from this page. This one I think, any question about, so no question about this page then. What about this one, exponential equations? Is there any question about these things? They have the unique way, which is you take logarithm of both sides, then move on. Let's solve just one from this. What's the page over there? Okay, let's go the previous page. I think for the previous page Elton wrote something like this. So for these ones, you should realize that the bases are different. Also, you should realize that 36 and 1 over 6, they are kind of similar ones. They can be both written with the base 6. 1 over 5 and over 125, they can both be written as base 5. So 8 and 128 can be written with the base 2. So if they have different bases, we check this. Can we simplify them just over there? Which is 36 is 6 squared, 1 over 6 is 6 to the power of minus 1, plus 1 over 5 is 5 to the power of minus 1, and 125 is 5 to the power of minus 3, plus 8 is 2 cubed, 128 is 2 to the power of 7. So then you can move the powers before the logarithms. So this number 6 will remain in there, but the powers, power minus 1 and power 2 will move here. And minus 3 and minus 1, the minus 3 from here will move over there, the minus 1 will move to the denominator part. So then there will be log base 5 of 5, and then 7 goes to the numerator part, 3 goes to denominator part. So that each of these logarithms are equal to number 1. So we can remove the logarithms right now. We can work with the numbers. Minus 1 over 3, minus minus will be plus 3 over 1, and then plus 7 over 3. So to be able to add those numbers, this denominator should be turned into 3. So from first, minus 1. From second, we will do the changing. 3 times 1, 3. 3 times 3, plus 9. And plus 7. 9 plus 7 is 16, minus 1 is 15. Over 3 is equal to 5. So now let's go to the next page then. Page 14, I have a comment in here. Let's check the comments once again. So let's go to the next page then. What about these questions I have asked? Page 14, perhaps we will, when we reach there, inshallah I can remember. Page 14. Okay, page 14. Let's move to the page 14 then. Page 10. So till page 14 we have these ones. Okay, that place is the page 14. Okay, so is there any question from here? From this one you say no question from here, but I have seen some mistakes about these examples in the quiz. I still couldn't write them to the so this is the page 14. So about finding the primary angles, we have like with the degrees and with the pi idea. With the pi idea is a simple one. With the degrees we are doing like this. We divide by 360, the remainder is the primary angle. 2000 divided by 360, the remainder. On the negative ones, let's show it with minus 900, can be a problem. Minus 900. So we don't care about the minus, we just divide by 360 equals, I think, 2 times 720. 0. 10 minus 2 is 8. 8 minus 7, 180. So that this means minus 980 is kind of an angle. One circle, sorry, in negative direction it should be. In negative direction, one circle, two circles. After two circles, it goes 180 more. So actually, the remainder is again a negative directed angle. We want to make it in positive form. So we say that from positive 360, we subtract negative 180. So that result is the primary directed angle. So then with the pies, it's the idea like you always look for before the number, before those numbers, which number is divisible by the denominator. Let's do one from positive, like 17. Before 17, 15 divided by 3. Yes, it's okay, but the result should be also an even number. So we go even before 15, we make it 12 pi over 3 plus 12 plus 5 makes 17, 5 pi over 3, which is 12 pi over 3 makes 6 pi. It means 3 full turns. After 3 full turns, this is the primary directed angle. So you write that it is equivalent to, it is not exactly the same. It can be counted same with 5 pi over 3. So then before minus 33, which number is divisible by 5? 35. But 35 over 5 is 7. We are looking for even number because we are looking for full circles like 2 pi. So multiples of 2 pi, 2 pi, 4 pi, 6 pi, 8 pi, 10 pi. It should be even. So you go even before 35. Before minus 33, there is minus 34, minus 35, minus 36. Go back, which is we use minus 40 pi over 5, which is going to be 8. So then this part should be plus. That's why we always go before. So minus 40 plus 7 is same with minus 33. We need to add 7. So after we decide what number to use in this place, we arrange this by looking the question itself. So minus 40 plus 7 I need to make it minus 33 over 5 stays the same. So this is equivalent to, you can remove the full circles and write that 7 pi over 5 is the primary directed angle. So enough. Page 14 is also done. I checked the comments. Let's go forward. These are the simple ones. In the quiz, I saw that everyone did this. What about this one in the quiz? I didn't ask for this in the quiz. Let's do 240 then. 240. Remember that if I ask you like a question like this, I told you that in the class. I want you to draw the part of the unit circle that we need. And I want you to draw this angle. To make it 240, it should be 180 plus 60, 240. After 60, I want you to write opposite of 60, root 3 over 2. I could have done it bigger size. Why didn't I do it? So I want you to write opposite of 30, root 3, 60, root 3 over 2, opposite 30, 1 over 2. Then I want you to write those points. This is minus 1 over 2. The y number in here is minus square root 3 over 2. Comes from this place. So sine 240 is the y number minus square root 3 over 2. So then cosine 240 is minus 1 over 2, which is the x number in here. So then tangent 240 it's sine over cosine minus root 3 over 2 over minus 1 over 2. Minus over minus is going to be plus. So then 2 and 2 simplifies each other. Square root 3 over 1. Cotangent 240 will be the inverse of tangent. We can write it directly. So then let's move to the next page. So I added this unit circle. Like first I want you to find the primary directed angle, like divide them by 360 and find the primary directed angle, then later show it with unit circle. It's the like connection of the previous example and this one. So then what about this? Is this the 7th? Was it the 17th page? Perhaps. I think he's asking about this. Okay, let's go one behind. Let's take this one. I want you to find sine, cosine, tangent, cotangent, all the trigonometric ratios of this angle. So you should divide this angle by 360. So 194, I think it was 5 times. How many times was there? I don't remember exactly. 720, 720. I think 4 times it can be. Let's try 4 times. 4 times 0 is 0. 4 times 6 is 24. 4 times 3 is 12 plus 3, 14. Am I true? I hope that I am. So let's subtract 0, 0, 5. It's bigger than 360, so it was 5 times. Let's check that. 5 times 0 is 0. 5 times 6 is 30. There is 3. 5 times 3, that means I did it wrong. I should put there like something like 5. So 150, you can go with that, because it should be something that you can show on unit circle. So later you will do the steps. Drawing unit circle for 150, there will be 180 minus 30, opposite 30 1 over 2, opposite 60 it will be the side root 3 over 2. I'm at the point, minus square root 3 over 2. The following steps like the previous page. I think no need to continue anymore for this one. So I am not able to follow the comments very well because it's hard to do it at the same time. Okay, I think right now it's okay. 17th page. So using the reference angle in here, I think no need for this one. Like when it's 330, you will write like 360 minus 30, then change or not change. Or this one you can write 270 minus 30. Let's do only these two. Let's see what happens. Okay, cotangent 30 will be a positive result, but sometimes the angle, the big angle in here may require a negative result, so you should check it. 240 is in which quadrant? It's in the third quadrant. So in the third quadrant it's positive, so you can keep it as positive. Then cotangent, when you use 360, you don't change the naming, you keep it as cotangent. Remove the reference angle, use the small one over there, which is small when I mean smaller than 90 degrees something. So this will going to be positive, this is going to be positive always. So we check that the real angle, the real question, does it require a negative result? 330 is in the fourth quadrant, so cotangent in fourth quadrant, cosine plus sine is negative, plus over minus minus, so the result must be minus. So minus cotangent 30. So you find the cotangent 30 from special right triangle, root cotangent quotient root 3 over 1. which is root 3, and this is minus square root 3. So what about these ones? These are very easy, but there are people who had trouble with these. Actually, I have given you a sin x. So it was the special right triangle, which is, let's say this is x, tangent x is 8, 15. I have given you 15 and 17. 8, 15, 17 is a special right triangle, like 3, 4, 5. Some people couldn't find it quickly. So now, do you want me to solve a question about this kind of types? I mean, these types. Like I give you the angle in which quadrant it is. So I give you one ratio, you put it on a small triangle. You also write like if this is the fourth quadrant, in the fourth quadrant, sine, cosine, tangent, and cotangent. You write sine should be minus, cosine plus, tangent, cotangent minus. So right now we have every result in here. So to write sine x, you can do it with x, 8 to 17. Cosine is 15 to 17. Tangent is 8 to 15. Cotangent is 15 to 8. So later you check that. See, we have a question, page 20. In the comment box, when you write something, please write it in English. Sometimes I try to read and understand. It really disturbs me. Kızım, ne oldu kızım? Ne oldu bakayım? Ne yapalım? Efendim? Senin alanında ders yapayım ama senin alana gelemem şimdi. Bir sürü şeyler var burada. Hepsini getiremem. Okay, now page 20 they want. So let's find the page 20 from the PDF 18, 19. Hey, page 20, good. So in page 20, the ones that we use mostly in here, like tangent is sine over cosine, cosecant, if it is cosecant, it should be a 1 over sine. With seconds is inverse. If it is just second, it will be 1 over cosine. These are the ones that we use mostly, and we also use the idea which is cosine squared plus sine squared is equal to 1. We mostly use this, a few of them, not so many things. Yes, there are many other things as well, but mostly those two. So from page 20, which question would you like? I can't choose, they all seem very easy to me. Let's do this one then. So tangent, I'm going to turn tangent into sine over cosine. That's why I also write the others as rational expressions, like this is sine x over 1 times the other is cosine x over 1. So cosecant, since like I have told just before, it should be opposite 1 over sine x. So right now there is something that we can simplify that I see over there. So then also in upper side there is a rational expression. Let's put it here directly, and then from this division we will change it into times 1 over sine x. We will flip it sine x over 1. So what comes from numerator part, sine x times sine x, it will be sine squared x over 1, which is the final result is sine cube x. So any other question from here? If we go forward, perhaps we can find some interesting ones. Like h seems interesting to me. I don't know. Let's go forward. So if I put it to empty page, it will be easier, better for me. So right now we have 15 people. Okay, that's enough. One of them is me. That means 14 people. So tangent, I am going to turn it into sine over cosine, and both of them will be squared. That's why I also write 2 as a rational expression. So then it will be sine squared over cosine squared x. So second is 1 over cosine. It should be inverse cosine squared. So then, to be able to make addition, to be able to simplify, I need to add them first. So to add them, I need to make the denominators the same. I need to multiply this by cosine squared x. So then there will be 2 cosine squared x over cosine squared x plus sine squared x over cosine squared x. Anyway, it's cosine squared x. I did write bad ama. Forgive me. 1 over cosine squared x. And minus 1, we should add over there, comes from here, minus 1. So I see it right now, like 2 cosine squared x plus sine squared x will be there. So if I write it like cosine squared x plus cosine squared x, this is 2 cosine squared x and plus sine squared x. I think I can make these two 1. These two equals 1, and over cosine squared x over 1 over cosine squared x. So these two looks like they are going to simplify each other. So I want to use the normal way that I always use. I don't want to make mistakes. So cosine squared x over 1. So what will come from upper side? Cosine squared x is the denominator. So that means they will simplify each other. Anyway, what's the numerator? These two are going to be equal to 1. So we will have in here cosine squared x plus 1. So there is also minus 1 following us everywhere. So let's simplify these two cosine squares. So there will be 1 for it, there will be 1 for it. So 1 times 1, the denominator is already 1. 1 times cosine squared x plus 1 is cosine squared x plus 1. And this minus 1 comes over there, follows us everywhere. So plus 1 minus 1 becomes 0. Cosine squared x is the final result. So now let's check the comment box. There is no other question that you want me to solve, so let's go forward. I think that should be enough. These are the similar things. So what about this? This is about the cosine theorem. What about this page? Is there anyone who wants me to solve a question from this page? I'm going to come in a second. I need to... a second. So now everyone, let's move on about these questions. So where were we? Perhaps I did it inverse. No, it must be inverse. I can turn it up. So right now about the voice, is everything okay about the voice? So about this cosine theorem, no one wrote me anything. So Do you want me to solve this one? No comment on the box, no message in the phone. That you want me to solve? Do you want me to solve any question from this page? No question? Sen wrote yes, but for which page? Let's do it for this page. Sen wrote yes to what? Perhaps he wrote yes to a comment. I can't follow it very much. So anyway, let's solve something like this. In the class I have told you, like, if you have x like this, so you need to find a common angle for small triangle and for big triangle. You call this as alpha, then for all this side 3, all this side 6. So it's like opposite of alpha 5. So 5 squared is equal to 3 squared plus 6 squared minus 2 times 3 times 6 times cosine alpha. So minus cosine alpha, let's move it in here. 2 times 3 is 6, 6 times 6, 36 cosine alpha. So then 3 squared 9, 6 squared 36 plus 9, 45 minus 5 squared 25 comes here. So then cosine alpha equals 20 over 36. If you simplify by 4, 5 over 9 it makes. So after you find cosine alpha as ratio, you use it to get x. So in the small triangle, opposite of alpha is x, which is x squared is equal to, around alpha in small triangle we have 1 and 4. 1 squared plus 4 squared minus 2 times 1 times 4 times cosine alpha. Normally you should write that step, but I'm going to change it directly like this. So then x squared is equal to 2 times 4, 8 times 5, 40. And this is going to be 17 over 1 minus 40 over 9. We should subtract those and put it into the square root. So now we have a message in the phone. Let's check that. Okay, now in here we have one other from phone. I got a message. Which question? I think it's from this page. It's B and E, I think. So this E looks hard. Let's solve this one. Or I see the result right now. So let's take this E. So I need the snipping tool for that. So let's do this E. One of your friends wanted me to solve this one. So right now here we have a question like opening square, which is here we have something like a plus b squared. So when you open it, let's take it down a bit. Remember that it's going to be a plus b squared, a squared plus 2ab plus b squared. We should write. After writing all, we also have additional minus ones in there, which is it's going to be sine squared x plus 2 times sine x times cosine x plus cosine squared x. This is the open form of power 2. After you open power 2, you should put there minus 1. So in here we are going to open it for minus, which is a squared minus 2a and b and plus b squared. B is cosine x, cosine squared x. and then after all we have another minus 1. So right now you need to see the property sine squared x plus cosine squared x is equal to 1, which is here you will have 2 sine x times cosine x. After that, sum of the squares is plus 1. You have next to it minus 1, which is going to be 0 in next step. So in denominator we have exactly same case. Sine squared x plus cosine squared x. 2 sine x cosine x in the middle staying same. So addition of these two makes plus 1 and minus 1 right after it. So that means this part's going to be 0, and here you will have those two parts. Can I copy it from here to there? Yes. So now check that. Plus 1 minus 1 is going to be 0. Plus 1 minus 1 is going to be 0. So we are dividing exactly the same thing. So it is going to be 1. But plus or minus positive over negative is minus 1 is the final result. So there was the question B as well over there. Let's try B also. So now let's make it bigger. By the way, I am planning to make the quiz for 11B in first physical education hour. For 11A, perhaps the last lesson is better. If you want in the 6th lesson, we can also do it in the 6th lesson. Or in the 6th lesson, you can still ask me some questions till the exam. So now, in here, tangent is going to be sine over cosine. Cosecant is going to be 1 over sine. Let's make them all like rational expression. Sine x times cosine x over 1, and this is sine x over cosine x for tangent, plus sine x over 1. Let's make them all like rationals because cosecant will be 1 over sine x. So later you keep the upper part same, sine x times cosine x over 1 staying the same, times sine x over cosine x will flip, it will be cosine x over sine x, plus the upper part stays the same, sine x over 1 times 1 over sine x is going to flip. So now let's do the simplifying. Sine x and sine x simplify each other, which is cosine x times cosine x will be cosine squared x over 1 times 1, which is 1, doesn't matter. Cosine squared x over 1. Sine x times sine x will be sine squared x. So this is the most well-known property, which is equal to number 1. There was one more message in the phone. Let's check that one also. Yep, I list all those two in here. Example C from which page? Which page? Let's write. From this page. So there is this problem, which is the moment that I'm talking, A, B, C. Example C, probably this one then. So actually in here you will write alpha, and this alpha will be the same. So for two triangles it will be the same. Okay, I see that. So let me show you this one also, which is, let's take this to an empty page. Sorry guys. So for this kind of examples, the examples which are in here, all of them, the important thing is we need to find an angle which is the same angle for both triangles. In here we use the top part. For the other one we can use this corner, which is the angle in this corner is inside the very big one, also is inside the small one. You can also use this corner, it doesn't matter. Look, you know the three sides for this triangle and you know the three sides for the big triangle. So in this example we know all the three sides, just one of them is empty. So we need to find something same for both triangles. So firstly you need to use the triangle which has all the sides are given. Let's try to start from here, which is opposite to alpha. Which number do we have? 7. 7 squared equals 5 squared plus 8 squared minus 2 times 5 times 8 times 5, 8 from here, cosine alpha. So I'm going to move this cosine alpha. 2 times 5, 10 times 8, 80. Minus 80 will become plus 80 cosine alpha. 5 squared 25, 8 squared is 64. 25 plus 64, and the 7 squared minus 49 will come here. If this was minus 50, it would be 14 in here. Now we can say that it's 15 plus 25, 30, 40. It's going to be 40 over 80, which is 1 over 2, which is that cosine alpha. So then you use it in the other triangle. Opposite to alpha we have x squared, and then 4 squared plus 8 squared minus 2, 4, 8. Then cosine alpha you should write in here firstly. In the next step you should change cosine alpha with the number. Now to be quick, I'm not going to do the third step. So you should write here 2 steps actually. So that x squared is equal to 16, 64. And then in 2 and 2 simplify each other. 4 times 8, 32. 64 minus 32 is 32, plus 16 is 48, I think. 48. So x is equal to square root of 48. If I remember, it was 3 times 16, which is 4 square root of 3 x. So now I got one more message from the phone. Let's check that message. So he's asking about the notebooks. Yes, I can take the notebooks on Tuesday, no problem. So now let's move on. By the way, I didn't check the comments for a while. Let's go back there. So there is no new comment. Okay. Some people are quitted. Probably they don't have the electricity, but it can be that reason. In dormitory. So now about this page, do you have any question from this page? What kind of questions were they? Like 8 over sine alpha, 12 over sine 60. It always goes like that. I think these were easy. What about this page? Is there any question from this page? So there is no message. So it's the page I have. So we have 8 more pages to finish. So these are some basic types of examples. Page 35, the rights. Let's find page 35 from the PDF page 35. Very good. 28 right now. I'm seeing the 28. You want me to solve from page 35. I won't put this question in the exam. Perhaps the other one, perhaps I can put that one. Yes, I did solve it in the last exam, last class. So I will solve this, but right now we are waiting for any question you want me to solve. These are some basic questions. So I think there is no questions from this page. You are all okay with this. Inshallah it's so. What about the ones with the shapes? So these are like x plus y, x minus y, and we are looking at from the shape. Is there any question from this page you want me to solve? Hussein, do the sixth one. What's the sixth one? I mean, what kind of six? The sixth one. Perhaps in page 35, the sixth one. No, there's no 1, 2, 3, 6 over there. Sixth one. Which 1, 2, 3, 4, 5, 6 is this one then. And this is the simplest one. What sixth? What sixth? 1, 2, 3, 4, 5, 6. Okay, let's say this is the sixth one. This is also easy one. Let's solve this one. This seems hard. I don't know. So something he wanted. Let's solve one thing. So now, tangent x minus y. So firstly, let's write the rule of it. Tangent x minus y. So if I remember well, we write the sign the same. Tangent x, tangent y. So in denominator, we write the opposite sign and their product, tangent x times tangent y. Actually, they are given. We are just going to replace it in the example. I think no need to solve this one, is even this one. Perhaps the others matters more. Page 28. Page 28, which one was that? This one was that. Page 28, which one is the sixth one? That's the problem. Sixth one, this one or this one? So I think I did solve this one in here. Like, let's take another question to this page from here. Let's take this one. This is like spatial right triangle. That is directly given. Haydi let's let's solve this one then. It is okay, page 28. So sine x plus y is equal to, sine is friendly, remember that. One for me, one for cosine. Keep it the same. So then x with cosine. So we need to put those numbers in. Sine x 3 over 5 is given, and cosine y is minus 3 over 5 is given, but we don't know the other two of them, so we should find them. This is the second quadrant from 90 to 180. Sine in here positive, cosine in here negative. So you draw two simple triangles with x in it. Sine x 3 to 5, 3 to 5, so the other side should be 4. So then you draw one triangle for y. For y, cosine y is 3 to 5. So then 3 opposite side becomes 4. So then cosine x from the x triangle 4 over 5. So later cosine x should be minus. So sine y from the triangle 4 over 5 again. So sine, we can keep it positive. Then we move on. It will be both 25. That will be minus 9, minus 16. When you add them, minus 25 over 25, which is minus 1. I think that's enough for this page. So what about the ones with the shapes? Do you want me to solve any in here? About the last page. Can I freeze this? I can't freeze this. I couldn't finish this one. I did till here. I did finish with the boys, but not with the girls, I think. Okay, good. So right now we are on this page. We have a few more pages. It's about to finish then. So now, is there any question from the shapes part? Do you want me to solve? Let's wait for a few minutes so I can get rest of it. So right now we have 11 watching. They all quitted. They all gave up, I think. So now from this page, you didn't write any comment. So I'm moving forward. What about this page? Is there any questions from this page? To the top right. Okay, let's go to the previous page. I saw a comment from about the previous page. Let's go there back. This one. I think because of this it takes it on. Haha. Go away. Find the tangent alpha. So it's a square which is every side is the same. And then whenever you have given such connection, use the namings like 3 and 2, they are the same one. 6, 3 times 2k, it makes 6k in the left side. To make 6k in the right side, it should be 3k over there. So DE is 2k, EC is 3k's. So then one side becomes 5k's. So there are two ways to do it, which is tangent theta equals. The first way, which is I am going to show in green and but not use this way. So this is the first way that comes everyone's mind, which is name this as x, name this as y. So theta is equal to tangent 180 minus x plus y. Since it is 180, you don't change the sign. And you use here x plus y. Later you should decide the sign. Since we are using 180 minus something, that means this is in the second quadrant. In the second quadrant, tangent is minus. You can go with this way, or I use a little bit geometry in here. Very tiny geometry. Let me show it to you in blue color. I add another line in here, which is if this one is 2k, the opposite is 2k as well. If this one is 3k, the opposite is 3k as well. So there will be 90 degrees. It will be right triangles in both sides. And since this is 5k each side, there should be 5k. So I'm going to name these two like x and y, which is tangent theta directly equals with the new idea x plus y. So then open this with the formula. If you have plus tangent x plus tangent y, so that over 1 minus, now you will have their product times tangent y. So then tangent x from here, tangent x, 2k over 5k, which is 2 over 5, plus tangent y from here, 3k over 5k, which is 3 over 5. And once you write them, it will be product of them in down. 2 over 5 times 3 over 5. So up there, 2 plus 3, 5 over 5 will be 1 in here. So since it's going to be 25 minus 6 over 25, I arrange number 1 into 25 over 25. So 25 minus 6 makes 19 over 25. And because of the 1, you flip it, 25 over 19 will be the final result. I did it a little bit quick steps. I hope that you understand this one. So now let's move to the next page. So these are the ones which double angles. Actually, you use this in here like x plus x. So any question from this page? I'm going to wait a little bit. Also, I'm really tired right now because of the illness, and I still couldn't prepare your exams. Oh, so now, do I have any comment about this? There is no comment about this. I'm going to move to the next page. So this is again with the double angles, which is you don't want something from double angles. What about this half angles? So for these ones you have formulas and you only use these formulas. What about this page? Do you want me to solve any question from this page? Let's wait a little bit. So we have 4 more pages to go, especially the last one. Problem 1 and 2, page 30. Let's check. Page 30, which one is that? It's this one, problem 1 and 2. Huh. What I understood, did I understand well it? So here we have examples, but you say problem 1 and problem 2. Okay. So now sine 40 can be written as sine 2 times 20. If I understood well, please write it in comment part. I'm going to solve these two of them, problem 1, problem 2. So we have a message. So 2 times 20, it's equal to 2 times sine 20 times cosine 20, which is 2 times sine 20 is already given is as x, so I need to convert this cosine 20 in terms of x. Normally I used to give like not 40 like sine 2x like the other questions. This is a little bit different. So I give you the angle as x and the result of it with numbers. Actually right now the angle given but the result like axis. So that's why in a small triangle we write 20°. We built a right triangle with 20°. So now if I want to write this x as a ratio of two things, I can write it x over 1. So opposite to 20x, the hypotenuse is 1. So it's all about calculating this part. Let's say a, opposite to 90, that side is going to be ln 1 squared. So a squared plus x squared, we will write in there. So a squared is equal to 1 minus x squared. So a equals 1 minus x squared inside the square root. So right now I can write that cosine 20 is equal to a over 1, which is a actually. So 2 times x times. I want it to be in terms of x, not a. So a equals square root of 1 minus x squared. So now what's happening? Anyway, I think I'm in the right way. So this is all done. We wrote sine 240 equals, and after this equals, I only used x and numbers. So what about sine 2x if sine x is given? So sine 2x is equal to 2 times sine x times cosine x. 2 times sine x is given minus square root 5 over 3. So I need to find the cosine x. So this is the third quadrant. So sine is minus, cosine is minus. So let's draw a small triangle with x in it. Sine x opposite to square root 5, 90-degree hypotenuse is 3, square root 5 over 3. So we need to find the third side. 3 squared, I'm going to do it in here. 3 squared is 9 equals 9 squared. Oh, come on, I did quick. I want to do quick. Actually, I can do it in my mind, Tama, just to show to you. So the other two sides, a squared plus root 5 squared. So a squared is equal to 3 squared is 9. Root 5 squared will be 5, and if you put it other side, minus 5. So a squared is 4, and a equals 2. After you find this, you can write that cosine x is equal to, since it needs to be minus after that coefficient, 2 over 3. Minus 2 over 3. So then minus times minus plus, and 3 times 3, 9. 2 times 2, 4. 4 square root of 5 over 9 is the final result. So problem 1 and 2 is done from this page. Let's move to the next one. This is again with the two extents, like the previous example. So what about this page? Half angle formulas. Do you want me to solve any from this page? So um, after I talk, it takes 1 minute for you to see it, the Saberja process. So it makes us waiting for each other. Do you want me to solve any question from this page? So it is better if you write me from Viber WhatsApp, it can be faster. So now, yes, please solve them. Tamam. Haydi, let's solve one of them. Just one of them should be enough. Let's solve the last one, which is the like common question that I can change as I wish. So let's take this to another page. Firstly, let's write the formula for tangent x over 2. Wait a second. This is cosine x is given, and when we write tangent x over 2, we will work with cosine x. Is there something like that? Yes, you see sine x is given. Let's do like that. Let's change this question. Let's make it funnier. So, firstly, let's write the formula of tangent x over 2. It's a very big square root. It can be plus or minus. later very big square root 1 minus cosine x over 1 plus cosine x. So then, since x is between 0 and 90 degree, tangent x over 2 will be between those two angles, which is going to be a positive result. So then sin x is given. So since this is a small angle between 90, I can put it directly over there, 4 and 5. So cosine x equals 3 over 5. So I'm just going to put them in this example. 1 minus 3 over 5 over 1 plus 3 over 5. So for each one, there is this step that I'm going to skip. 5 over 5, I can write. 5 minus 3 will be 2 over 5 times 5 over 5. I can write 5 plus 3, 8 over 5. You will flip it. You will make it 5 over 8, which is going to be 1 over 4. 5 and 5 simplifies each other. 2 by 2, 1. 8 by 2 is 4. So this is tangent x over 2, which is square root of 1 over 2 is 1 over 2, positive 1 over 2. So now, yeah, in the comment box, I have page 32, example 1, cosine x over 2. So I think this example is kind of helps you to understand that one also, I think you said. Uh, it's kind of like the same. So you write the formula, then later you put cosine thing in, and then find it. So what about this page? What's that? So these are long answers. I will certainly ask one of those in exam. So you need to know the things that you should write. Let's remember that you need to, if you need to prepare a unit circle. And for example, if you are doing this, you need to write that this is cosine x. If you are doing tangent x, you need to draw this line and write that this is tangent x. If you are making cotangent x, you need to draw that upper line, the horizontal one, and write that this is cotangent x. After that, you need to prepare this table x and cosine x from 0 degree to 360 degree. Later, you should write the properties like the 4 properties, so you can just memorize what they are. Later, at the end, you need to draw this graph from minus 360 to plus 540. I think I wanted something like that. So now, is there any other question about this page you want me to answer? Let's wait a little bit. And this page is about like it's 1 plus 1 minus 1. Like when it's 0 degree, sine 0 degree is y number 0, cosine 0 degree is 1. It's something simple. I think the questions are in this page. And then for comparing you look for the quadrant, which quadrant they are. So if they are all the same, it's easy. So by checking the quadrant, you can order them. So for example, can I change these? Okay, let's change these numbers and make it an exam question. So let's say this is 185 or 4. I can't put my phone in there. And let's say this is 240. And let's say this is 100, not 100 and 230. So I want you to order them. So you check that these angles, they are like from 180 to 270. They are in this place. So sine third quadrant, was it increasing or decreasing? Let's remember, sine third quadrant. You go to the third quadrant, sine, it's 0 in here. When it's in here, it's going to be minus. From 0 to -1, that means it is decreasing. That means like biggest number will be the smallest result. Sine 240, smallest result. Then sine 230. Then sine 184 will be the biggest result. Will we have questions including period of trigonometric ratios? Period of trigonometric ratios? The last one, I'm not so sure about the last page. I mean, this page, I didn't complete it in the 11A. 11A won't have a question for sure, but 11B may have. And these are some simple stuff if you remember. So let's end this live video. I'm going to wait like a few more minutes if you have any question. So as I told, still didn't prepare the exam questions. What I saw right now, they look all like easy to me. I don't know if, since I know the results, perhaps they are easy to me. I think I really removed a lot type of examples. So by the way, until I wait for the last, let's remember this. Normally the period was like, how was the period? For sine and cosine, it was 2 pi. Come on. And for tangent and cotangent is 1 pi. Since sine and cosine has the graph like this, when you have even powers, the graph will be like the part you need to go down should repeat up, the part you need to go down should repeat up. That's why, so normally it was different, now it becomes the same, which is when you have even powers for sine and cosine, you will calculate it as pi. And then you only care about what's before x, the coefficient of x, and you keep it as absolute value of -2. Let's check this one. Second is 1 over cosine. So since it is odd, I'm going to use 2 pi and absolute value of -2. Cosecant, it's 1 over sine, so it's like sine. And since it is odd power, I'm going to use 1 pi. Normally I want to use 2 pi. Since it's even power, 1 pi I use, then over 4 is the period. If you have any, I'm at school now, the power was up for a few minutes, then it's down again. Okay, Chamebov, this is the life. Uh, I'm I'm really asking, if you want candles, I can bring them. Do you really want candles to study? If you could not buy, of course. Or, and if you have any other question, I'm going to wait like 2-3 minutes. Let's I can solve it right now, or else I'm going to stop this video. So now I see no question in comment box. Hussein, is he writing something in comment box? So the comments that I read, they are like from 1 minute before. It's not kind of like same moment. I don't know that. Can I follow it from here? If I follow it from here, no, Hussein just wrote the point. Perhaps if I follow it in here, it will be like 100% with the timing. Which is the screen. Oh, we did 1 hour 30 minutes talking. Oh, I'm so tired. Anyway, guys, I think it's time to end this. If you have any other questions, you can write me from Viber WhatsApp, and I can open one more live and or just video of it. Thanks for listening to me. It really helps for me because I get VVF. My VVF timing is increasing. Thank you. Good night. If you really need candles for dormitory, please write from Viber WhatsApp. I will bring them. I'm so I'm not feeling very good, Ama. I will do it for you. Good night. Last time. Okay.